Well, hello Ninthers. I'm hoping that all of you are doing well, all of you are doing fine, along with members of your family and also your near and dear ones. Also, I'm hoping that you all are keeping in touch with your studies, and please, it's a kind request, or you may take it as an advice, that not just the prescribed textbooks, due to the extra time which you all have got due to the lockdown, please try exploring so many other different things, so many other different books, so many other different topics. Try to read a few novels and try understanding, exploring, and also finding out about newer and newer things. Now, when in the previous video, I did talk about volcanoes, and while I was talking about volcanoes, I mentioned something about a magma chamber. In the comment section, I did receive a request about what actually is a magma chamber. Now, when we are talking of now once again, I'm just asking you all, if you all do have any such problems, any such queries, any such difficulties in understanding some of the topics, some of the concepts, some of the other terms, then please try, or then please ask it in the comment section, so that I can get back to you in the next video which I'll be uploading. Now, when we are talking of a magma chamber, what actually is a magma chamber? Or let us just, you all know what the asthenosphere is. Asthenosphere we had talked about in a previous lecture. Asthenosphere is nothing but the less rigid, or that liquid part of the mantle on which the lithosphere is resting. Suppose this white part, this white remote in my hand, is the asthenosphere. While I'm talking of the asthenosphere, let this be the asthenosphere, and above this, it is a layer of the lithosphere which is directly above the asthenosphere. The lithosphere is quite wide. The lithosphere may be stretching up till this height, but I'm just talking of the layer which is resting just above or is in direct contact with the asthenosphere. While I'm talking of this, just keep in mind that the asthenosphere is very hot. It is less rigid. The particles over, or the rocks over here, are in molten state. What actually happens is that this, due to some reason, due to some cracks in this boundary area of the between the lithosphere and the asthenosphere, what may happen is that the asthenosphere, or the materials, the molten materials in this part of the asthenosphere, rises up, and it moves towards these areas of the lithosphere near the boundary, and it comes in direct contact with the particles. It comes in direct contact with the rocks of the lithosphere. So if the molten material from the asthenosphere is rising up, this part of the lithosphere, or the rocks of this part of the lithosphere, is coming in direct contact with the molten materials of the asthenosphere. Those molten materials are very hot. What is actually happening next is that these rocks, when coming in contact with the molten materials of the asthenosphere, these rocks are melting, and when these rocks melt, these rocks are forming, or this molten material over here is forming magma, and this area over here where the rocks are being formed, or the magma is being formed, this area is converted to a magma chamber. So this is how a magma chamber is formed, when the material from the asthenosphere rises up due to some cracks, and it comes in direct contact with the rocks of the lithosphere, and these rocks then melt because of the extreme heat of the materials from the asthenosphere, and the rocks, when they melt, they form the magma chamber. And most of the volcanoes which are found on the earth are located directly above the magma chamber. So this was about the magma chamber. Now, the next topic, the next chapter, is about earthquakes, or is earthquakes. What actually is an earthquake? In the previous few weeks, you may have heard, if you all did keep in touch with the news, that many such small earthquakes rocked the national capital and also the northern areas of India. And national capital, that is Delhi. I hope everyone knows that. So, what actually is an earthquake? Let us just break the term. Quaking, the term quake in English, the literal meaning of that word quake means to shake. And earth, as you all know, is the earth. So when the earth is shaking due to vibrations caused underneath the earth, when there is some kind of, or when the rocks are releasing their energy, the stored energy, the potential energy of the rocks, that potential energy of the rocks, when it gets released, that causes an earthquake, or that causes vibrations to move on the surface of the earth, which causes us also to vibrate and which is causing the earth's surface to shiver and to quake. That is actually an earthquake. What is seismic waves? Seismic waves are nothing but those waves which are causing earthquakes. Those are the vibrational waves. Suppose you are standing, suppose you are standing on the floor or on the ground, and some distance away from you, a very heavy rock falls on the earth. What will be happening? You will be feeling the vibrations. Now the rock fell at some distance from you, but you felt the vibration standing at the point you were standing. Why did it so happen? Because when the rock fell when the rock fell on the ground some distance away from you, as it fell, it had its own weight, and due to that weight, there was some kind of an impact on the ground, and that gave rise to vibrations. And those vibrations traveled to you, causing you to feel those vibrations, or causing the land on which you were standing to vibrate. So this is what is, these are nothing but seismic waves. So seismic waves are formed when the rocks release their tremendous energy. You may be questioning, how do the rocks, or from where are the rocks getting those energy? Now let us just, once again, let me take the help of the remotes. Now, okay, this is the smaller remote, and this over here is the larger remote, the bigger remote. Let us just think that these two remotes, at some point of time, they were joined together. And these two remotes, at some point of time, they were like this. They were one rock. Let us not forget that these are remotes, these are rocks now. So two rocks were not two. These two, both the rocks together made up one rock. So this is a single rock. Now, due to some earth movements, what may happen is that the rock will be undergoing some kind of folding or faulting. Folding is maybe if there is compressional force from both the sides, then the rocks may be folding. And if there is tensional force, or if there is pull from both the sides, then the rock will be, or there will be some kind of a pulling. And this pulling or this folding causes we all know that rocks are not elastic. Rocks do have some kind of an elasticity, but that elasticity is not much. So if there is enough amount of tension, or if there is enough compression, or if there is enough pulling from both the sides, what may happen is that there will be a fault. What is a fault? When there is a crack. When a crack comes in between the rocks, that gives rise to a fault. So now the point where these two remotes are joining, suppose these two areas, now there is the fault over here at this joint. Now this fault is storing a lot of potential energy. Why so? Because there is actually a crack over here, and this crack will have to someday or the other, or the rocks over here are not in a very stable position. Why are they not in a very stable position over here? Because the rocks are being continually being either pulled aside or being compressed. Now due to this compression or being pulled aside, the rocks are not stable over here, and they will at some point or the other want to stabilize themselves. And when they want to stabilize themselves, in order to stabilize, what will the rocks do? The rocks may either go up, or the rocks may fall down. And if there is any such movement of the rock, then that will be releasing a huge amount of energy. That is what we know as seismic energy, or that is what is one of the reasons which gives rise to earthquakes. So you understand now from where we got the energy. The energy which we got over here is due to the folding or the faulting processes, and those folding and the faulting processes which we are seeing are giving rise to a lot of or tremendous amount of energy, because the rocks will want to stabilize themselves, and until and unless they stabilize themselves, they will be storing a lot of potential energy. And the moment they stabilize themselves, suppose so as to stabilize this area, so as to stabilize this fault, this part of the rock falls down. When this falls down, a huge amount of potential energy is released, or maybe this part of the rock comes up, then also a huge amount of potential energy is released, causing earthquakes. We'll be discussing about this. Now there is another thing. Let us just discuss a few terms right now. What are or who are seismologists? Seismologists are those people who scientifically study about earthquakes. What is seismology? Seismology is the scientific study of earthquakes and of the different other or different reasons which give rise to the earthquakes. Now, what is a seismograph? A seismograph is an instrument which records the vibrational activity of the earth, and it gives us an idea if a bigger earthquake is about to come. And what is a seismogram? A seismogram is a graph kind of a thing on which the seismograph records its observations. You must have seen a seismograph. It is nothing but a needle like thing placed on a graph paper, and it is allowed and it is free to move, and as it moves it records the vibrations. It looks similar to a electrocardiogram or an ECG of the heart of a person. So if you all just search it in the internet, you will be finding a few other terms. Let me just see the terms over here. Epicenter. Epicenter is or the seismic focus. Seismic focus is that area. Now suppose this is the area I am talking about. This area or these rocks over here are lying below the Earth's surface. Now the point where this fault area, where the earthquake or where the vibrations arose or where the vibrations took place, this area is called the seismic focus. And just above the focus, directly on the ground, that area which will be perpendicular or which will be perpendicular and which will be lying on the Earth's surface, that will be called as the epicenter, or that is known as the epicenter. So epicenter is that area directly over the surface or directly on the surface of the Earth which lies perpendicularly below the which lies at a perpendicular from the seismic focus. Now these are some of the terms. Now there are so many ways to measure the intensity of an earthquake, but the two most important ones are the Mercalli scale. Mercalli is an Italian scale, and the other scale being the more prevalent scale is the Richter scale. Now the Richter scale is an exponential scale. That means that the amount or the variation between the Richter scale is measured from numbers 1 to let me just see, I'm forgetting this. Well, the Richter scale, I'll just tell you about the name of the person. It was developed by an American seismologist, Charles Richter, in 1935. And well, the Richter scale has its it ranges from 0 to 9, with 0 being the least or with the least intensity and 9 being the highest intensity. But then a few times on this earth, earthquakes have been measured more than 9 intensity or more than 9 Richter. Now while I'm talking of exponential, I told, or logarithmic, what it actually means is that if suppose I have 1 Richter scale and there is an earthquake which measured 1 Richter scale, and there was another earthquake which measured 2 Richter scale. So the difference between the intensity will be 10 times. The first Richter or 1 Richter scale and the difference between the 2 Richter scale, the intensity difference is into 10. Now when I am talking of the 3rd Richter scale, then the difference between the 1st Richter scale and the 3rd Richter scale will be, the intensity difference will be into 100 times. So the 3rd Richter scale's earthquake will be 100 times more powerful than the 1st Richter scale's earthquake. Now if I am talking of the 4th Richter scale, it will be 1000 times more intense than the 1st Richter scale. So that is the way it keeps on moving. If I am talking of 2 Richter scale and 3 Richter scale, it means that the 3rd Richter scale will be 10 times more powerful than the 2nd Richter scale. If I am talking of 5th Richter scale and the 7th Richter scale, then the 7th Richter scale will be 100 times more powerful than the 5th Richter scale, and the 6th Richter scale will be 10 times more powerful than the 5th Richter scale. You will understand this. I'll be in the next video, I'll be just showing you mathematically what it actually means. And the Mercalli scale is not on the intensity, but the Mercalli scale is designed by the amount of destruction or the amount of harm which a earthquake may cause. So the Mercalli scale is based on the amount of damage which a earthquake causes, and the Richter scale is based on the intensity of an earthquake. These are different terms. We'll be understanding all these in the previous video in a much elaborative way. Now, if we are talking of the causes of earthquakes, one of the most important cause of an earthquake is a volcano. How does a volcano give rise to an earthquake? Last class or last video, we were discussing about how a volcanic eruption is occurring and how a volcano erupts. When we are talking, or let me just revert back to the remotes once again. If I'm talking of this as the Earth's surface, the white part is the Earth's surface, and the black part over here is the magma chamber. So the magma chamber or the magma will want to rise up towards the Earth's surface, and as it starts moving up, it will be finding a crack, and if it does not find a crack, it may find a softer layer on the Earth's crust. And we were talking about two kinds of lava, acidic lava and the basic lava. The acidic lava contains huge amounts of sulfur and explosive gases. Sulfur is an explosive gas. Sulfur is found in, or sulfur is one of the main ingredients of gunpowder. So sulfur is an explosive gas, and acidic lava is very, very rich in sulfur. Now if this lava, this magma chamber which was formed, if this, now you may be asking, how do we get acidic lava, how do we get basic lava? The rocks, the rock composition, if the rocks which formed the magma chamber over here, if these rocks which were forming the magma chamber were rich in sulfur deposits, then we will be getting a acidic lava, and if they were not rich in sulfur deposits, we will be getting basic lava. So this acidic lava will want to rise up, and if it finds a softer part over here on the Earth's crust, what will happen is that this acidic lava, due to its explosive nature, will explode out of this area, and this explosion causes a huge vibration, or this explosion causes huge vibrational energy to come out, causing earthquakes. So this is one of the most important reasons, or this is one of the most important way by which an earthquake is formed. And most of the areas around the circum-Pacific belt, or in the previous class we had discussed about something about the Pacific Ring of Fire. So the volcanic eruptions which happen over there are most of the times accompanied by earthquakes also. And one of the most destructive effect of earthquakes which happen below the Earth's, or which happen below the below the ocean's bed, is tsunami. So what happens is that when the Earth's surface below the ocean, or when the ocean's bed is vibrating, that vibrational energy is given to the, or that vibrational energy is passed on to the water above it also, and the water starts, due to the vibration, the water starts moving in different directions, causing huge waves to form. And those waves, as they move closer to the harbor, or as those waves move closer to land, what happens is that those waves rise in height, and these cause tsunamis. Tsunami, the word tsunami is derived from the Japanese two words, harbor and waves. Su meaning harbor and nami is waves. So harbor waves. Why? Because those waves were very dangerous, and those waves became that high just when it reached the harbor, or just when it was about to reach the land. So this was one reason. The volcanoes are one reason why we have earthquakes. Another reason we just discussed while we were talking of these two remotes, or we took the help of these two remotes while we were talking of, or while we were discussing about the folding and the faulting. So these folding and faultings may also cause earthquakes, and they do cause earthquakes to occur. Now another very important reason why earthquakes occur is human activities. Well, the earth is balanced right now. What happens is that when we do something, or the earth on its own is balanced, the crust is not, or the pressure of the crust is uniformly divided all over. Now what happens is that if we give extra and a huge amount of weight on the crust at a particular area, like building a dam, what do we do when we build a dam? We make a huge, or we dig that area, and huge amount of water gets stored in that area. That huge amount of water over there, the water has its own weight, and that huge amount of water is giving an excess amount of, and an extra amount of, it is giving an extra weight on the crust and the rocks which are lying underneath the water, under the Earth's surface. That extra amount of pressure and the extra amount of weight which is lying or falling on the rocks below the Earth's surface over there, that extra amount of rock is that extra amount of rock which we are that extra amount of pressure is or may at times cause the rocks over there to just become disbalanced, and another thing, faults may occur in that rock over there. Why? Because there is an extra amount of tension or compressional force acting on those rocks, and due to this extra compressional force which is acting on the rocks may at times dislocate from their origin or original place, or the rocks over there may at times develop faults and cracks, and these cracks over there which develop in the rocks may at a future time or uh, in the future may cause an earthquake. Because as I just discussed, that when there are faults, when there are faults or when there are cracks on the or in the rock surface, what happens is that the rocks and the rocks which are lying around that fault area will want to stabilize itself, and when it wants to stabilize itself, a huge amount of potential energy is released, causing an earthquake. We'll be leaving till this part in this video lecture. In the next video lecture, we'll be covering the other parts and the other aspects of earthquake, and also we'll be discussing how tectonic movements cause earthquakes. It will be similar to that of folding and faulting, and also we'll be discussing about the effect of the earthquakes, and also we'll be doing about the two scales in a bit detail. So till then, please stay safe, be safe, and keep enjoying. If you all do have any problem, please mention it in the comment section so that I can answer it to you. Thank you.